Hello, Dave Soriano, chemistry professor with the University of Pittsburgh's Bradford campus in northwestern Pennsylvania. This is a small introduction, a brief introduction to fossil fuels and uses, which I offer in my petroleum and natural gas chemistry course for petroleum technology, and I also use it in a course titled Chemistry and the Environment for environmental studies majors and some other majors on campus. Perhaps you'll find it helpful. Fossil fuels in the year 2000, if we consider them 85% of the United States energy consumption. That's changing, of course, with growing economies in China and India. But 86% worldwide, 85% the fossil fuels. And coal, oil, and natural gas can be considered. All differ simply in the ratio of carbon to hydrogen. Non-renewable. I don't think there's too many geochemists that believe that oil is being replenished right now anywhere on the surface of our planet or towards the interior. Now, how much reserves are available? That's one of the important questions to consider. Reserve versus resource. Fossil fuels, due to different availability and utility, have different markets, and reserves also vary accordingly. Coal. First fossil fuel used on a large scale. It's still 23% of our global energy source. In most industrialized countries, coal has been replaced by oil, gas, and/or electricity in household uses. And electricity generation from coal is still very important. Worldwide, 40% of electric power is generated using more than 60% of the global coal production. Poland, 95%, South Africa, 93%, Australia, 77%, India, 78%, and China, 76%. We're talking about coal for electricity production. In coal-rich United States, 92% of coal production produces 51% of the electricity. Most of the rest, of course, is being generated by nuclear means. Coal combustion. Vaporized water pressure temperature-driven turbines, generators. The combustion of coal is what drives the turbines, which generates the electricity. Coal is also used for steel and cement manufacturing. China and the United States are the main global producers of coal. We are blessed with massive resources of this fossil fuel. Very high energy density fuel. The United States reserves still very large and widely dispersed. Proven resources are close to 1 trillion tons. An awful lot of the low-grade brown or lignite coal is coming out of the Wyoming, North Dakota, South Dakota area. About 170 years of supply at the current rate of consumption. Global coal reserves are significant. The coal quality has as much importance as the actual size of a country's reserves. Coal quality depends on caloric value, carbon and water content. Lowest grade would be your lignite, peat, essentially peat would be the lowest grade. Anthracite, of course, in the eastern part of Pennsylvania near the Scranton area, is a very, very high energy dense coal. And the maturity of a given coal deposit has a lot to do with the coal quality. Here in western Pennsylvania, we're right here in the heart of the Bradford oil fields, and the Colonel Drake Titusville first producing well, circa 1870, is still that we have a campus there, Titusville campus, and we're in the heart of the oil fields. We're also touching upon the Marcellus natural gas shale play. The coal line starts in Kane, Pennsylvania. That's approximately 20 miles south of us. It's not a good grade coal, but it's the beginning of the coal line. And as you go south, you're getting more and more towards the coal producing regions in western Pennsylvania, in the Pittsburgh region. We're about 3.5 hours north of Pittsburgh. With high pressure temperatures millions of years, lignite is transformed into bituminous coal. High water content, friable, and burns with a smoky flame. As geological processes continue, hard coal forms. Further maturity converts bituminous into anthracite. Sulfur coal content in coal samples is very critical. The Rocky Mountains coal is bituminous, but has 85% less sulfur. Coal is expensive to transport. During the past 20 years, however, price of coal has declined as productivity and transportation have improved. End user costs, however, increase as environmentalists call for clean coal. Coal has greater environmental challenges versus oil or gas. Sulfur dioxide, nitrogen oxides, particulates, mercury, arsenic, lead, and uranium can be detected. With proper processes, coal can be burned cleanly and efficiently, but it is still producing global warming gas CO2. Compared to oil and gas, it produces the greatest amount of CO2 per unit of energy generated. Oil. Petroleum-derived gasoline and diesel fuel are most obvious products. Oil production increased rapidly after World War II. At the start of World War II, the United States was the Saudi Arabia of the world in terms of proven reserves and the refining of oil. This came to a dramatic decline at the end of World War II. About 1950, the United States no longer was producing and refining oil the way it was before World War II. 2004, 30 billion barrels of oil produced, 35% of the world energy supply, coal 23%, natural gas 21%, and nuclear 7%. Worldwide, 6% of oil becomes chemicals, dyes, pharmaceuticals, elastomers, and paints. The bulk of oil is used for heating, electricity generation, and transportation fuels. 2/3 of oil is used for transportation applications. Global demand for oil has risen 2% yearly, and of course the demand will be based on the global economies. Still sufficient oil reserves are known to last at least the next few decades. Considerable debate about the amount of oil existing worldwide and the percent that can be recovered economically continues, and oil will not be exhausted overnight, but market forces will drive prices up as demand exceeds supply, creating a true and lasting oil crisis. Tar sands, the most prominent unconventional oil source. Sand deposits containing a high sulfur tar known as bitumen, formed by the erosion followed by evaporation of volatiles. Canada and Venezuela are major sources of such fossil fuel. Canada, the Athabasca and Cold Lake deposits are being worked. 12% of the oil is considered recoverable. This amount is equal to the current proven resources of Saudi Arabia. Some of it is being piped right here locally to Warren, Pennsylvania, to an oil refinery, to the best of my knowledge, just about 10-15 miles west of us. It's being piped down from Canada. The amount is equal to the current proven resources of Saudi Arabia. Production depends on production costs, and 1 million barrels are produced daily in the Athabasca region of Canada. Oil shale. Oil shale is a source rock that never sank deep enough for the organic matter to produce petroleum oil. Shale oil contains neither shale nor oil. Kerogen, a solid bituminous material that can be a substitute for crude oil. When you heat this to high temperature, thermal cracking produces oil, which can be refined to petroleum distillates. Global reserves of oil shale are enormous. Production had peaked in the early 80s, with Estonia producing 70% of the world's supply. Largest known deposit in the world is the Green River region in western United States. Shell, Exxon, Amoco, Unocal, and Occidental have had pilot plants using different extraction technologies. Large amounts of heat are needed to process the oil shale, and disposal of the large amounts of expanded shale rock must be addressed. Oil Tech Incorporated of Utah claimed they had a production cost of less than $20 per barrel. Tar sand oil shale technologies are actually quite similar. Natural gas. Over the last 30 years, global demand for natural gas has grown much faster than coal or oil. We can, in principle, from natural gas, which is mostly methane, CH4, in principle, we can get all of the chemical feedstocks that we need, that we currently get from the petroleum, and the bulk of our methanol, methyl alcohol, is produced from natural gas technology. In 2001, 21% of global primary energy sources was natural gas. The United States uses 1/4 of the global natural gas demand. And of course, since I put this lecture together a little while back, we now see the United States for the first time in decades actually exporting fossil fuel, namely natural gas. The United States is the second largest gas producer after Russia. Natural gas is considered a premium fuel and is environmentally much cleaner than petroleum and much, much cleaner than coal. It has high caloric content, clean burning, and relatively easy to handle. Petroleum and chemical engineers can handle natural gas. We can, in principle, as I said, get all of the bulk chemicals, the chemical feedstocks we need from natural gas technology. It's an excellent fuel for domestic use and heating. The bulk of future demand will come from electricity-producing power plants. In the United States since 2002, please make note of the typo there, 2002, virtually all electricity generating capacity is from natural gas. Peak load power plants prefer natural gas for turbine utilization. Natural gas adds the smallest amount of carbon dioxide to the atmosphere per unit of released energy. Keep in mind that methane itself is a potent greenhouse gas. It's 23 times higher in damage than carbon dioxide over a 100-year period. You don't want methane escaping into the atmosphere, even though it probably has been doing it for thousands of years in places like northern Canada from methane hydrate pools. You can actually see the methane gas being released from these pools. I show a film in class on this. From 1750 to 2000, 20% of cumulative greenhouse effect was due to methane. The largest sources of anthropogenic methane derives from livestock, rice fields, and landfills. Yes, from cattle belching, producing sizable amounts of natural gas, methane. It's estimated that there's at least 70 years supply of natural gas left and 40 years for petroleum at current rate of consumption. We have to take into account economy and population and recent discoveries of plays like the Marcellus Shale in northeastern United States. As with oil, a few countries dominate the natural gas reserves, and we saw just up until recently Russia, Iran, and Qatar in the Mideast being large natural gas reserves. Like oil, the natural gas is concentrated in a small number of giant fields. In order to ship natural gas overseas, LNG, liquid natural gas, must be produced at portside liquefaction plants in the producing countries. The condensed liquid is almost pure methane. It is then regasified at destination port. This process is very capital intensive. Each plant involved is $1 to $2 billion in construction operation. This concludes the brief introduction to fossil fuels. I hope you enjoyed it. Thank you so much for listening.